is management of technology and innovation industry dynamics. And the second talk will be on technology strategy. Basically, taking you along in order to connect what are the digital frameworks which are available, connecting it the applied aspects that how multinational companies actually utilize these frameworks, or but they are their technology strategy. So that would be a discussion. But in this part of discussion, I thought, what are the things which I can share with you? So then I realized that whenever I make some basic discussion on innovation, what is innovation, what is innovation that is discussed in innovation, technology. So from there we will begin and slowly we will talk about industry dynamics. So, as you know, the business environment today is characterized by all these features. That is, continuous change is happening, uncertainty and complexity is very much there. Every day, new business enterprises are getting born. Old ones are dying. There is some competition in the marketplace in order to survive. But to talk about those challenges are that more difficult. Cut competition is being there, not only between multinational companies, but multinational companies are also coming in developing economies. So that's why more dynamism is added when these big players enter to emerging economies like India, and they, with their strengths in technological, financial, and organizational capabilities, they compete with the domestic players. So, as far as the domestic players they also compete among themselves because the action out there is very complex at times. So, there is pressure from stakeholders, and you know who are the stakeholders in business. It is not only the company itself or the consumers, but there are a lot many other actors also there in the scene. So who are these actors? Can we enumerate them?
Shareholders, there are
suppliers, customers. Each and every party which is associated with the firm is stakeholders.
NGOs are there, governments are there. They all are stakeholders. They have certain expectations from the business. So that means we are having the pressure on the firms in order to get their expectations fulfilled. So in this whole process, the firm itself has to fulfill its expectations this type of pressure from all directions on the business activity. The impact of technology, especially ICT, has been tremendous in the last 2 decades. And I don't think there is any aspect of our life which has not been touched by information communication technology. And similarly, businesses have also got influenced by the changes which the ICT has brought along with it. So, as one of the former chairman and CEO of Untitled Chapter, Piyush says, whatever made you successful in the past won't in the future. That means the kind of strategies, the kind of business models, the kind of products which have been successful in the past with all these changes on the anvil, with the same kind of strategies we cannot expect to survive or to come forward. So that means you need to invent, innovate on each and every count, almost on all the dimensions if you really want to be futuristic and then too if you want to be successful in the future. So this is the type of complexity the business environment has today. So why innovation all of a sudden has become important? I would say rather it has always been important. It is not something new which is happening, but rather the pace with which the innovations are happening, or we are realizing then we are getting touched by them. That is, the pace has increased. But earlier the pace was a little bit slow. In a moment I will talk about the waves of innovations which we have witnessed. Some of the waves we have witnessed in our lifetime, but some have been exerting shaping the economy of the world economic order in yesteryears. So why innovation? Consider these two facts. In the first graph, on the x-axis we have taken the year, and on the y-axis it is the lifetime in years. So this graph is all about average lifetime of Standard & Poor's 500 companies, and this graph clearly shows that the average lifetime of these big 500 companies, the 500 companies which are taken as a sample for this study, has decreased from 60 years to 15 years. That means the earlier the organizations or the business entities which were there, they had an average lifespan of 60 years. But now it has been reduced to just 15 years. So what are these factors? What are those factors due to which this lifespan has decreased?
State competition, changing business environment, the requirement of
the need of customer
Preferences of the
changes
customer
every
are
time.
changing.
Technology changes as well.
Any other factor?
Business environment.
Yeah, complexities are there, and we are witnessing a tremendous globalization on almost all fronts. So that means the companies are not only competing in their domestic markets, but they are facing competition from outside also. So, but the fundamental premise is that the innovation, because the companies who are who are new and are challenging the established players, what are the basis on which these companies are competing with them and are ultimately becoming successful? It is the innovation.
diverse business.
That is there. And the second graph, second chart, this shows on x-axis again it is years, and then the probability, on the y-axis it is the probability that a company in an industry's top revenue quintile will fall out of it within 5 years. That is another indicator of how innovation is impacting the businesses. That means, in a way, we can say that the businesses of today are making most of their money from the innovations or the products which are just 5 years old. That means the new products are the basically products or the business, the revenue streams on which the businesses are banking. That means every now and then new products the need for new products is realized and they are getting developed and making the older ones obsolete. So they are slipping on as far as earning revenue for their respective entities, business entities is concerned. So these two facts make it clear that innovation is very important. Innovation has emerged as a dominant, I must say, if I could use the words technology and innovation interchangeably, I would say technology has emerged as a dominant factor of production. And anybody from an economics background?
We have studied actually economics in our UG and PG.
So, thank you very much. So, I understand that you would have earlier heard about this concept factors of production. So, you know, historically, traditionally, the way they were talked about land, labor, capital, and then we talked about organizations, that is the role of entrepreneurs, because land, labor, and capital are scattered across the planet in different quantities with all their natural characteristics and other attributes. But it is the entrepreneur who organizes them in an economic activity, brings them together, and economic activity is born out of it. So that means the role of entrepreneur is also important, and that is one of the explanatory variables with the help of which we can explain the different degrees of technological innovation capabilities which different parts of the world have, or the economic growth or the economic development which have been registered by different nations. But few organizations, few nations, like organizations are very good at it. They have that type of a environment, conducive environment, whereby the entrepreneurs are motivated and incentivized to undertake the economic activities. While in other economic contexts, there are certain barriers due to which the full potential is not harnessed. So that means the organization or the role of entrepreneur is the fourth factor of production: land, labor, capital, and the entrepreneur. The fifth factor of production is technology. So as somebody was saying, we have machinery. So I would say machinery is an artifact of innovation or technology. So that I can replace it with, I would like to replace it with a term called technology. So these are some of the innovation ways which this world has witnessed so far. Starting from the left-hand side, the first wave, that is the 1785 to 1845, the iron ore mining, steel production, uh, steam engine, that is the water power, hydraulic, mechanization, textiles, commerce, etc. So they led the wave of economic development of the growth of the world in that period. Then the second wave is steam power, railroad, steel, cotton, etc. They ultimately became the drivers of economic growth across the in certain parts of the world. Basically, Europe and America. Third wave, electricity, chemicals, internal combustion engine. So they led the growth. These sectors started very big growth, leading the growth from the period 1900 to 1950. The fourth wave is attributed to petrochemicals, electronics, aviation, growth in aviation technology, space technology. Fifth wave is digital networks, biotechnology, software, information technology, and this wave hitting the economic scene, we all have witnessed. We all are an eyewitness to this particular wave, making a tremendous impact across the globe, and India has also been touched heavily by this and have gained out of it, I must say. The sixth wave. Now again, another issue is very much emerging on the horizon, and people have started talking about it. It is really the need of the hour. That is the need for sustainable innovation. So whatever we have been doing till now, so I will not go deep into that because then it would call for a departure from the topic which we have decided for the day. But I hope that all of you understand that how sustainable innovation is now becoming the core issue. So that means sustainability, radical resource productivity, whole system design, biomimicry, green tech chemistry, industrial ecology, renewable energy, the green nanotechnology. These are the emphasis areas. So, which will ultimately drive the growth in the times to come in future. So we have talked about the importance of innovation, influencing the world economy. So how do we define innovation? So innovation can be defined as coming out with a new workable idea by combining various kinds of existing knowledge and experience in a unique manner. So that is how we generally define innovation. So there could be different approaches to which we can define a particular concept, and this is the I think the easy to understand way to define what the innovation is. Because if I assume a little bit economist viewpoint, I would say innovation or technology is the coefficient of factor in government. So now it is something very complex, which take some time to explain to what does it mean. But in simple terms, we all can understand that it is the new workable idea. So innovation is the transformation of creative ideas into useful applications. Till the time it is in the skull, it is science. The moment it is on the table, it is technology. So that is maybe a metaphor which I can use in order to explain what do I mean by innovation. Then we often use these terms interchangeably, that is invention versus innovation. But they have to be understood clearly. There is slight difference. So I must say that the slide is very huge also. Invention, creating something new, that is new knowledge, that is you conceive something. But what is innovation? Innovation transforms that idea and resources into useful applications. New products, services or processes are created. That means innovation is an act. While when we talk about invention, it is conceiving. That yes, combining these different streams of knowledge, we can do this. But the moment you convert it into a useful application, that is a innovation. That means what I'm trying to say is we all appreciate Apple and use these products and products. So I would say the core technologies on which these products are built were invented much earlier than that. Before the Steve Jobs actually could visualize that these pieces of knowledge or this science can be used to make a device on which we can listen music, or which can use as a phone, which can be used as other type of functions which we perform. That means there is a clear cut difference between invention and innovation. So innovation is the outcome of innovation is new product or service or a process which has some that means a value is created. And an entrepreneur is a person who is interested in appropriating that value. When you pay for these devices, so the money is going from consumer to the business. So that means the value which he has created by innovating these products, services, processes. Now he is trying to realize the value, appropriate the value through transaction process or through market mechanisms. So some of the basic dimensions of innovation are two basic dimensions. One, they are novel, they are new, and they have certain utility. Right? So innovation has to qualify on both the parameters. That is, it is novel and it has some utility. So novelty does not mean new to the world. It does not mean that it is only for the first time that this device has been created. It can it qualifies to be called by innovation, even if it is new to a community, to a country, industry, company, or for a new use. So till the time it is new in its context, continuous improvement is critical to commercial exploitation, and that we all know that whenever new product is introduced, slowly there is a period when gradually some incremental improvements are happening over it. But we have some time on it because that is the close thing which will be talking when we discuss the industry dynamics. So continuous improvement is critical to commercial exploitation of innovation and sustaining the competitiveness. Because if you don't further improve it, very soon you will lose your competitive advantage and the revenue could be out there in the space. So the types of innovation, as far as Oslo manual is concerned, these four basic types of innovations we generally talk about. One is product innovation. What do we mean by product innovation? A good or service that is new or significantly improved. This includes significant improvements in technical specifications, components, materials, software in the product, user friendliness, or other functional characteristics. So as far as the basic function of iPod is concerned, that we all use for listening music. But we have been listening music earlier also to different other devices, right from gramophone to radio to cassette players, tape record,
CD players.
CD players, and then Walkmans were there. This iPod is an innovation, is a product innovation because it is new, it's significantly improved, Technical specifications are altogether different. Components, materials, software, everything is.
Basically miniaturization.
So, yeah, we will touch that point in a moment. So you are right. Process innovation, but it is much more than that also. So let's first talk about the types of innovation. Process innovation. What is process innovation? A new or significantly improved production or delivery method. This includes significant changes in techniques, equipment, and software. So every time you upgrade your operating system on your phone, that is not taken to product innovation. That is simply moving on to the next level of interface within the device. So because this new interface enables now device to function more efficiently. So that's this software improvement is a sort of a process innovation as far as improving the functionality or efficiency of that device is concerned. So marketing innovation, a new marketing method involving significant changes in product design or packaging, product placement, product promotion, or pricing. So we all are making use of online portals in order to do different types of transactions and purchase different materials. So when one may argue that whether it's a process innovation or it's a marketing innovation, I would say it is both. So depends from which angle you are viewing it. Because this IT-enabled platforms are a process innovation for these retailers in order to make their products reach to your doorstep. But at the same time, this is the same vehicle which they are utilizing in order to promote their products. So equally called innovation also. Organizational innovation, a new organizational method in this business practices, workplace organization, or external relations. So many organizations and IT has really helped creating this type of innovations, because nowadays we are also talking about moving from brick and mortar structure to virtual workplaces or virtual organizations. So that type of innovation also. So then we have another aspect related to innovations, that is technological versus social innovation. So for the last few minutes we were dwelling more on the technological innovations, but we have witnessed the social innovations also. And these innovations have been very powerful in bringing changes in our lives also. And these, what are social innovations? How are they defined? Like mail, educational system, social system, healthcare, social interaction, social media, etc. So these are they have completely changed the way we interact with each other. So technology has enabled us to interact in a much more efficient and effective manner. So thus, different aspects of innovation are there. So based on the degree of novelty, the innovations can be classified into different types. Like they can be systemic innovations, or a small component innovation, or they can be, or on other scale, it could be incremental or radical. Like for example, we can start with component and incremental. What type of innovation is happening over here? Improvement of components. And when we talk about radical innovations, these innovations are new for the world. That is, advanced material improving component properties. Today we are talking about foldable display screens. So that means that is based on altogether a new science. That is a radical innovation. That is no more a component innovation. So system innovation, a new series of cars, planes, computers, etc. So this type of innovations are in this category. While this is systemic and radical innovations, steam engines, information communication technology, biotechnology, nanotechnology, etc. So depending upon the degree of novelty which is there in these innovations, we can classify the innovations into different categories in order to develop and understand about what type of technological improvement or change we are having. Then this is a innovation process, the outcome of which is a new technology or a innovation. So as you know, this is a funnel. What is this? So existing knowledge is used as a input. So the advancements in science and technology or accumulated understanding or accumulated knowledge about the space in which we are living, about the world, that is going as an input into this process, and this knowledge is combined in order to create something. So that could be new knowledge itself, or it could be an innovation which has some practical use. So from idea generation to incubation to prototyping to launch, more knowledge is used as a input in this process. So that is the innovation process. So then you know the success rate.
So please last. What is this stage prototyping? Incubation is the first stage, na innovation. And
Yeah.
what is
So
prototyping?
you have conceived something, now you want to develop, you want to test it, and you want to really use that knowledge which you have in order to find a solution to some problem. So that means I'm talking about what is happening at the lab stage. So you are working on those pieces of knowledge, you are trying to integrate them, and with the help of that you are trying to come up with some sort of a solution. That
This is the action-oriented stage.
yeah, action.
Making prototypes basically.
The outcome of this incubation phase would be a prototype.
Like
That is a sort of a workable kind of a solution, but it is not full-fledged with the final product.
like we make simulations generally.
The simulations.
Model.
Developing a model.
Model. With the help of
So,
simulations only.
simulation means to say you want to forecast or extrapolate that if these be the features,
Set of the input, what will be the corresponding output?
and how it will ultimately fit into my objectives and help me in realizing those objectives. So simulation is a technique or is a step in that direction where you try to assess whether the kind of things which you are bringing into your model will really help towards that or not. So then comes the prototyping. Prototyping, you just put together the bare minimum stuff and see whether it works in the actual world or not. So then, depending upon the response or depending upon your experience, you pivot.
Simulation come between the idea of generation
Idea generation,
and innovation.
lots of stuff can come inside it. But in order to give you a broad overview of the innovation process, so I'm just focusing on the major stages. That's it. So when we talk about building technological capabilities in a moment, then maybe I'll try to pitch in some new pieces of information which can help you. So I hope this is clear.
Yes.
So the innovation tunnel is there, existing knowledge is used as process input. Then we ideate, we generate some idea, we incubate, prototype, and ultimately launch. So the outcome of this knowledge combination is creation. Then creation is by innovation. And you know the success rate in this whole journey is very less. So that means this is according to an estimate, according to some studies, that the most innovative ideas do not become successful new products, and we all know that. So thousands of raw ideas are generated ultimately as they move from these different stages, generation to incubation to prototyping, launch. Many of them are killed in the process. So you realize that they are not workable. So on the basis of that, you cannot develop a successful product. So ultimately, those who pass this rigorous test, they see the light of the day. That means they are ultimately into the market, which are again competing with the other solutions. So that will come. So on one hand, where we are talking about this innovation funnel, that means the success rate of this idea is very low. On the other hand, there is another dynamics which is out here as far as technology and innovation is concerned, and that is the technology life cycle. So, as you would have used this S-shaped curve in different other disciplines also, so sinusoidal kind of movement. So in engineering, you have definitely studied that. So it depends on the axis where you draw the axis. But let me just move forward. So this technology life cycle curve, what does it explain? It simply explains that with the passage of time, the performance also improves. So in the early stages, there are certain issues. The technology or the innovation is not that mature, but as the time progresses, the performance starts increasing. The existing technology or as the technology matures, the performance increases. It increases rapidly. That means based on that existing knowledge or technology, the performance is enhanced significantly, and that the solution based on this technology or innovation established itself as a dominant design. What is dominant design? Just to give you a clue, otherwise in a moment we will talk about that. Like today, a few years back, almost a decade back, we all were using the old kind of bulbs in our home. So whenever a new home was constructed, those kind of bulbs were put in because that was the dominant design of that day. And then came an era when we replaced those with tube lights. So that means choke and those kinds of plates were fixed everywhere because anyone who wished to install some lighting system, these were the kind of technologies which were very acceptable. So the provision for them was made. And then we moved to CFL, and then we are now talking about the LEDs. So LEDs are first nothing as the dominant design. Otherwise, the CFLs have already established themselves. So in this room, CFLs are there. So they are yet to operate in LED. But it is not very far away. Very soon they will realize that that is the way they have to move. So that means in those days, the performance of CFL, some scientists in the lab would be working at the stage of, I don't know, imagination, idea generation, or incubation, or prototyping. But the established or the dominant design was something else. But what has happened very soon, this technology matured. CFL technology matured, and it emerged as a dominant design, replacing the old technology. And then again, now it is nearing its maturity stage.
Saturation.
So that is the development slows as its limit is approached. So we cannot say further. We cannot make it better. So that is maybe the limitation right now, but you don't know because I would argue sometimes the true limits of the technology are also not realized because in market there is so much dynamism that people a new wave of technology will come or innovation will come and they will wipe this technology out of the market. But few decades later, sometimes realize that was a good one and maybe we can use again. And that has happened as far as the music industry is concerned. So, you know, I would say that gramophone, this were a very much primitive kind of a precursor to the CDs or DVDs which we use nowadays. But you know, in between, everybody discarded them. Those who are fan of it, they would have definitely preserved the gramophone disc. But you know, that technology was replaced by video cassettes, that is recorders, and active recording, that kind of stuff. But again, we have realized, maybe a little bit improvement in materials, the kind of magnetic surface which is there. With that, we can again write a huge amount of data on a smaller disk. So,
This is also a kind of
yes.
download.
Exactly, that's what I'm trying to say. So, what is happening? The other dynamics which is happening is this technology life cycle. Generally, this is the way the technology should behave. So that means there is a early stage, then there is a huge improvement stage, and then comes maturity, and then comes the decline. But this technology life cycle is not equally long in each technology's case. Few technologies they never get a chance to get mature. They are killed very rapidly, while others are there for a longer period of time. For example, you would have definitely witnessed that change which has happened as far as mobile telephony is concerned. We had those kind of basic landline phones, and then came a device called a pager.
Pager.
Isn't it? How many of us purchased it? Only one person purchased it. That means, so you were, I would compliment you, maybe you were an early adopter, right? Because by the time I could take a decision, there was a next best solution which was already into the market in the form of a mobile phone, right? So now you can understand the technology life cycle of that product was too short. And those who had made a bet on that technology had made some investment in that type of a business, they would have failed to realize its full potential, business potential, isn't it? Because the next technology is very soon in the market, and there are no takers for it. So that type of a dynamism is happening. With all this information communication technology, with all these rapid changes which are happening in science and technology, and as a technical teachers, as a engineering and technical institute faculty, you also are contributing to that because you are very rapidly trying to bring the latest advancements in your discipline to your classroom and telling your students to start using it because it is more efficient. So that means you in a way are also contributing in making this technology like shorter and shorter in some way. So making it very difficult for the businesses to capitalize the gains, isn't it? So that type of a complexity is there. So ordinarily, generally, the technology dissemination pattern and the adopter categories are like this. We are talking about this only. That percentage of adopters is on x-axis and time on y-axis. So you see this green line is a very much cumulative S-shaped curve in the technology. So this is the curve which tells us about how many percentage of people. So this is the distribution of people how they adopt the new technology, how quickly they adopt the new technology, or we can say technology dissemination or its adoption rate. So only 2.5%, or very few people, those who have money, those who can take that risk. So they quickly adopt our new technology, which is on the right. So how many of us have a hybrid car? None. So you know that those who have money, those who can take that risk, they know that this technology is not yet mature, but yes, that is the future. So maybe those kind of people would be appreciating the technology and making a purchase decision right now. Then there are these figures are based on some studies in which they conducted some sort of a survey. They analyzed the technology innovation diffusion trends among a large number of people, and then they plotted this distribution. So 13.5% fall into the category of early adopters, 34% of the majority, 34% of the late majority, and rest 16% are the laggards. So that means these are the people. And then we can have a separate discussion on this also, because if we are interested in knowing what are the personality traits of these different types of adopters, that also we can discuss, isn't it? But to just float some pointers, you know that the innovators are the risk taker ones, those who have the resources, while the laggards ones are very conservative, and they won't move to the new technology unless it becomes very crucial for them. Because without that, it is not a survival. It is difficult to survive. Only then they will move on. While majority of us, the good news is like we may be falling between early adopters or early majority. Right? So, so we have just talked about the technology cycles becoming shorter and shorter. That type of a challenge is there. So what is happening? Why and what type of explanations we can give for this type of a phenomenon? Why these are becoming shorter? Anderson and Ashman, they argue, they explain this with the help of this model. The technological change proceeded cyclically. that this is a sort of a technological change, or cycle of technological change. So each discontinuity inaugurates a period of turbulence and uncertainty, that is an era of ferment, until a dominant design is selected, ushering in an era of incremental change. So since it's a cycle, so we can start anywhere, but let's start from here because that is dominant design selected. So a few moments back, I was just giving this example of old bulbs, incandescent lights, and then we talked about tubes and CFLs and LEDs. So, wasn't some 10 years back, that was the dominant design. And what was happening? There was an era of incremental change which was going on. Slowly, people were trying to make them better and better, and they're trying to improve their efficiency, but using the broader framework of that technology. So that means elaboration on the dominant design were happening. So people were trying to experiment with the materials, or trying to minimize the usage of certain materials, or trying to minimize the electricity consumption, thereby increasing the efficiency and its performance. So that was there. Then comes the technology discontinuity. That is the next wave of technology or innovation which has hit the market for the form of CFS. So once this technological discontinuity, why we use these terms, these words? So that is very important. So they are very important to understand. Discontinuity. That means whatever was happening earlier is now no more relevant. A new types of dynamics is emerging. So that means a new technology is bringing some sort of a discontinuity to the existing technology. So the moment this new technology enters, there is also a phase which is called era of ferment. So what is happening in this era of fermentation? I hope you all know fermentation. And how do you define fermentation? Lots of dynamics and chemical changes happening in it. It's very difficult to define what actually is going on. So that type of a dynamics is there. Complexity is there. So in era of ferment, what is happening? Design competition. What is design competition? That means the existing design, that is the dominant design, and the new technology, they start competing with each other. So you may find people are divided. They will say, no, this technology is not yet mature, this is not the right time. Maybe we should wait and watch. And since it's a new technology based on altogether a new science, so its performance is also not that good. So like we have discussed in the previous slide, there are certain problems with that. So that type of a design competition is happening between new technology and the incumbent technology. So as a result of this design competition, what happens? Substitution. That means survival of the fittest. So the technology which is able to establish its superiority over the other one is substituted. So it substitutes the poor one. So that means substitution happens. CFL has substituted the tube lights. So now the dominant design is CFL. And what is happening in CFL? Again, the era of incremental changes. I'm confused what I should use. Is going on or was going on? So era of incremental change is there. The improvements in CFL technology was going on, but now this technological discontinuity in the form of LED. And then I heard some of my students were talking about there are other lighting solutions which are very fast emerging now. So we are yet to witness that change. So this is what the technology cycle is. So what we have discussed so far, let's synthesize them so that we put them in a proper context and are able to understand the final points of it. A dominant design always goes to command the majority of market share unless the next discontinuity arrives too early. That means if the next technological discontinuity does not arrive too early, this new dominant design will rise to command the majority market share. So if next discontinuity arrives too early, like it happened in the case of pagers, it never commanded the majority market share. So Dominant design was never in the same form as the original discontinuity, but was also not on the leading edge of the technology. Because once it was introduced into the market and it started competing with the dominant design, it had certain issues like poor performance in technologies, non-feature. But ultimately, when it is established, it is altogether a step change or a great improvement from the way from the form in which it was introduced into the market. It bundled the features that would meet the needs of the majority of the market. That is the explanation why majority of people or the market would shift to the new technology. Because this now new technology or new innovation is able to satisfy the needs of the majority of market, majority of market or the majority of customers. During the era of incremental change, firms often cease to invest in learning about alternative designs. That is also one of the important aspects of the behavior exhibited by the firms itself. Instead, focus on developing competencies related to dominant design. Once a dominant design is selected, a new technology is there. According to this research, majority of the firms, they also cease investing on finding alternatives because it is not in their best interest. So what is in their best interest? In order to capitalize gains from the new technology. And how they can capitalize it? By bringing incremental improvements in it. Right? So that means what I am arguing is, once you have taken a decision that you are going to buy a particular configuration, so the next morning you are not going to change it. You will not think about investing it. Rather, you will make all those investments to which you can bring incremental improvements in its performance. Isn't it? So, because R&D is risky, we have talked about the innovation tunnel, thousands of ideas to pass through this process until you are successful. So that means lots of money, effort, and time is at stake. So this also explains, in part, why incumbents firm may have difficulty recognizing and reacting to discontinuous technology. Since majority of the firms are now interested in incremental improvements and are not focusing on finding an alternative solution, so therefore at times they will fail to appreciate the next discontinuity which is emerging on the horizon. So people in the board may taking positions, no, this is not the good solution, this is not going to be successful, so let's focus on this technology has still the potential, or things like that. But all of a sudden, you realize that the next technology is way ahead of the existing solutions which we are making use of. So, so far what we have talked, with the help of please remind me about friends who are 10 minutes and then just give us a
10:40.
okay. So we were talking about this is the technology cycle which is going on. That means discontinuity established itself as a dominant design, and then there are two phases, incremental change and the design competition that is happening. But why is this happening? So the explanation for this is there are two primary sources why dominant designs are selected at all. Why any technology becomes so influential that it emerges as a majority market choice. So there are two reasons. One is learning effect, and another is network externalities. So, so what is learning effect? In the first chart, on x-axis it is cumulative output, and on y it is cost per unit. That means, as you know, as you produce more, the cost also comes down. So that means, as the cumulative output of the technology increases, its cost also comes drastically down. It becomes more affordable for majority of people, and thus it emerges as a preferred technology or the solution of the product. Secondly, as the cumulative output increases, performance on each unit also increases. So that means as more and more that technology is made use of, understanding around that technology is also developed. Many more people start working on that. So they will also start contributing to it, and the performance will also increase. Like for example, in mobile phones, we talk about Android applications. Android as a platform now, many users are working on it. Many new applications are coming up every day, and the more and more applications are around it. You find it more convenient, and thus it overall increases the performance of the technology itself. So two things are contributing to it simultaneously. The cost is on one hand coming down, and second thing, performance is also increasing. So in order to harness the learning effects, firms also, or there need to be an absorptive capacity. So a firm's prior experience influences its ability to recognize and utilize the new information. So the firms who have this capability to absorb the new knowledge, or have the people or have the teams in place and have the resources in order to understand what this new technology is all about, they are able to absorb it better than the firms who don't have the absorptive capacity. So, second source why dominant designs are selected are network externalities. So that is what I have just a few moments back discussed with you. The more it is worked on, the more it is in sync with other things, the more beneficial it becomes. So in market, the network externalities, the benefits of from using a good increases with number of other users of the same unit. And you know, people argue. If I may have your attention, please.
Yes.
So, which operating system do you have on your laptop or your PC?
I am using Windows 7.
So, how many of you are using in Linux?
I have a dual booting system.
Since you are, I am asking the right question to a wrong audience, or the vice versa, because all of you are technical teachers in technical institutes, so you may be having
Actually, we are bound to have two systems because of viruses. If at all there is and we have important data, we boot in the Linux, get back it. Because Ubuntu is one of the operating systems in which we can access the Windows partitions.
Thank you very much for this piece of information. The question was, majority of the users, not you, in your family, in your acquaintances, would be using Windows, isn't it?
Yeah.
So that is the operating system which is used by majority of the people. Why? Because you know the kind of other add-ons and other things which are available around Windows operating system, they are not that much available, or people are at least not aware of the same or how to use it. That's why the dominant design is, as far as operating system is concerned, is Windows. So there is no argument on it. So as far as the technological superiority is concerned, as you have rightly pointed out, Linux is no inferior to Windows, I must say. So rather it has certain advantages, but the only thing is that the network externality, that is the point I precisely want to emphasize, that in markets with network externalities, the benefits from using a good increases with the number of other users for the same. The same is the case of Android. So network externalities also arise when compatibility or complementary goods are important. Like for other users of PCs, say for example the kids, they are more concerned about which types of games they would be able to play, or the type of audio, video, media which they would be able to play, than the technical things which we might be interested in. For them, it matters more. And the more these type of products, the complementary products, are in sync with this type of technology, the likelihood of it emerging as a dominant design also increases. That is the argument. So one more dynamics is there, that these the technology cycles are reinforcing in nature. How they are reinforcing in nature? A technology with wide range of complementary goods attracts users, and increasing the installed base. That means, assume there is a X installed base. That is the size of the installed base. That means there are two technologies for which there are 100 users, and there is another technology for which there are 10,000 users. So hypothetically, we can extend these figures to the same case: Windows versus Linux. So now you know the size of installed base influences the availability of complementary goods, isn't it? Because a large installed base attracts producers of complementary goods also. Because if as a software development developing firm, a firm which is into developing video games or writing other programs, algorithms around that thing, so the availability of complementary goods will also increase around that technology. And more the availability of complements, the availability, it will further reinforce the installed base. So that is the kind of a loop which gets activated due to these two sources which I just mentioned: the learning effects and the network externalities. So apart from these dynamics, there are certain other factors also which play a great role in establishing a technology or innovation as a dominant design. And they are rather easy to understand, like government regulations. Sometimes the government regulations are framed in such a way that they favor one type of a technology. Like you know, the general standard for mobile communications in Europe is GSM, but in USA it is CDM. So if the law is like that, then you know the likelihood of CDMA being a dominant technology in US is more, and the GSM in and the kind of standards which we have for our building offices and houses, the kind of switches and things like that. So all of the companies, the switch manufacturers and others have to comply to that. The kind of voltage which is there is a law. So according to that, you have to build all your appliances and other things around that only. So the government regulations also play a very significant role in this emergence of dominant design. And one more factor is winner take all markets. That means the early entrant, the technology which got a strong foothold into the market earlier than the veterans, have a more likelihood to emerge as a dominant design. Okay. So that means we can almost argue on every count the kind of devices which we make use in our day-to-day life, are they the best solution? And if you will deeply introspect, then you may find most of the time it is not. And that's why the next innovation wave is heavily centered on sustainable innovation. Because the devices or the products which we are using are somewhere adversely affecting our environment or other aspects related to sustainability. So they are not the effective ones, the efficient ones. We are in the pursuit of finding a better and better, maybe the most efficient solution is a mirage, but we definitely should not be satisfied with the status quo. So, how do we define innovation? So this is what we have a few months back we have talked about definition which is expressed in high alphabets. So here I would just like to put it in a different way. Think about innovation distribution. On y-axis it is number of ideas, and x-axis it is the impact that innovation creates. So from the perspective of impact, like earlier we were talking from the degree of novelty, we can classify the different types of innovation into different categories, whether they are systemic or component, whether they are incremental or radical. Similarly, on the basis of impact which they create, we can also categorize them. So you may find incremental improvements, Kaizen. So I think those who are into mechanical engineering, so they would have heard about these terms. they are related to authority management, authority management, Six Sigma, those kind of things which we talked about. So incremental improvements, that is the most of the time they are we are encountered with the ideas which are just incremental improvements, but the ideas which are radical, disruptive, and game changers are very rare and very few. But in terms of impact, they make tremendous impact as compared to the incremental organizing kind of solutions. Because there's a concept of value. When we talk about impact, the innovations make, we are somewhere talking about the value which these innovations contribute. And this concept of this term value, or this concept in itself, is multidimensional in nature. So, what do we mean by multiple dimensions of value? Basically, there are two things: technology's standalone value and the network externality values. What is standalone value? It includes factors such as the functions that technology enables consumers to perform. Second, its aesthetic qualities and its ease of use. That is its standalone value. That means, with an example, we can say you have a Samsung phone and you have a Apple phone. So they have their own functionalities, their own features, their own aesthetics, and the ease of use is also over there. So that means they have certain standalone value. That means the value of Apple is independent of Samsung. That is there. But the network externality value is whether this Apple, if you make a decision in favor of Apple instead of Samsung, what else you will be able to do. So that is also a contribution to its value. So that value is network externality value. It means the value created by the size of technologies installed base, as I gave the example of Android. So that means if you buy an Android phone, so you have option to download any apps from hundreds and thousands of apps and Android apps which are developed.
Play Store.
So at one point of time, the Android's Play Store was much more richer than Apple's. And Apple also invested heavily into it, and it made it a part of their technology strategy, that they created same kind of a huge Play Store around the Mac. So that means the standalone value is one thing, the network externality value is something on top of it. So that is again linked to the same discussion which we had a few moments back, that is the installed base and the availability of complementary goods. They reinforce each other. So basically, we were talking about design competition, that when we said that the impact of radical and disruptive innovation is far more than the incremental innovations. So, and then we invoke the concept of value in order to explain that how this impact is created. So basically, we are again converging onto the same point to explain how these dominant designs are selected. So consider this chart. Assume this is the starting point. So what is the overall value offering of a technology? It is made up of three things. One is technological utility, which it offers. Second is its installed base, how many users are using that technology. And third thing, complementary availability of complementary goods. A new technology competes only on the value of its standalone utility, that is the technological utility. Because a new technology is new to the market, you don't have this installed base around it, and you don't have availability of complementary goods around it. So on which basis, on which ground it can compete with the existing dominant design? Only on the basis of technological utility. That means this new technology or innovation has a huge value of it as a standalone product. So that means new technology that is compatible with existing technology installed base and complementary goods has a high likelihood of emerging as a dominant design, because this new technology is offering you huge technological utility, and if this new technology or innovation has somehow some support derived from the installed base also, and the availability of complementary goods, the likelihood of it emerging as the next dominant design increases. So that means where lies the difference? The difference is this one. Just notice this gap, which is over there. And from where this gap is coming? From the technological utility. So that means if the new technology is already in sync with the installed base and complementary goods around it, the probability of it emerging as a dominant design is more. So, though I wanted to discuss a few more things with you, but in the interest of time, I would just stop over here. Thank you very much.